Okay, Stat 1150. We've talked a little bit in the previous videos. Actually, we've talked quite a bit, or at least I've talked about it, about how to numerically describe quantitative data. And what we talked about things like means and medians, which are measures of center, typical scores, range, standard deviation, quartiles, interquartile range, which are measures of variation. So if we're someone who, like me, I'm more quantitatively impressed than I am with pictures, but a lot of people like pictures. So how to graphically summarize quantitative data is the purpose of this video. And specifically, I want to get into histograms. So first of all, the theme that your author uses is see it and summarize it. So let's assume that we have some data. Actually, we have quite a bit of data I've already written down. And let's say that these data represent the number of goals scored in a 2012 season for Division III female soccer players. So if we look at this data, and we might reasonably want to know what is the typical goals scored, and is a 19 unusual. So these might be kind of driving questions that for some reason or other, maybe we're a researcher on for the NCAA, who knows, you know. So anyway, I'm going to take you through ways that we can see this data and we can end up summarizing it. Now, the very first thing I would want to do here is I'd want to start looking at some patterns. So I would probably start trying to organize this in what we call a frequency distribution. So what I would want to do is I would want to create some bins. And I can see that my data range from 35 to 9. So I'm thinking about that. I've got this difference from 35 to 9, which if my mental arithmetic is correct, that's about 26. And from previous experience, I know that if I can get about 7 bins, then I'm going to get a pretty good look, a pretty good width of the bins, the widths of the bins. It makes no sense probably now. Trust me, it will be. So from experience, I know if I can get 7. So I just mentally divide 26 by 7, and I get about a 4. Okay. So I'm going to start out with a number below the lowest. So I'm going to start out with 8. And I want the first bin to be 4 units wide. So with an 8, a 9, a 10, and 11, the first bin will go from 8 to 11. The next bin will obviously not want to start to 11 because then we wouldn't know where to put an 11. So it's going to run from 12 to 15. The next is going to run from 16 to 19. The other from 20 to 23. Pretend there's a 23 there. The other from 24 to 27, 28 to 31, 32 to 35. Because I started a little below, you'll see I get 1, 2, 3, 4, 5, 6, 7 bins, just kind of like what I intended to get. The next thing I'm going to do is I'm going to go in through and just look at the frequencies. Let me get this thing focused a little bit better. Okay, so from 8 to 11, I have 1, 2, 3, 4, 5 frequency. From 12 to 15, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. From 16 to 19, I have 1, 2, 3, 4, 5, 6, 7, 8. From 20 to 23, I have 1, 2, 3. I have no scores from 24 to 27, 28 to 31, and I have 1 from 32 to 35. Now, I can see here that I can sum this up, and I have what, 16, 24, 25, 28 numbers. So I could also create what's called a relative frequency distribution. So 5 out of my 28, get my handy dandy calculator here, gives me 0.18. 11 out of 28 gives me 0.39. 8 out of 28 gives me 0.29. 3 out of 28 gives me 0.11. 0 out of 28 gives me 0.00, 0.00, and 1 out of 28 gives me a 0.04. Now this is going to round, be very close to 1 when we add up. Now, you know, it could be off a little bit because I rounded some things, so there could be some rounding issues. Now, what I would want to do is I'd want to take this information and I would want to look at a picture. So if I look at a frequency distribution, then I'm going to use the frequencies. So on my vertical axis, I'm going to see that I range from a 0 all the way up to an 11. So I'm going to accommodate the vertical axis with my frequencies, and I can see that my bends, and guys, I'm going to come in here and break this up because it's not going to be symmetric, will range from about an 8 to a 12 to a 16 to a 20 to a 24 to 28, 32, and we need to go to 36. So the frequency distribution would just create bars up to the frequency in the range of scores that we've created from our bins. So this one would go up to an 11. I'll tell you what, this kind of stuff wears me out. I'm going to do a few more, but then I'll lose my patience. Go up to about an 8. And then we would continue in the same manner. Now, the only difference in a relative frequency distribution is we would have exactly the same setup on the horizontal axis. But the relative frequency, as we see back over here, ranges from 0 to 1. So I would probably break this up into 0.25, 0.50, 0.75. If these decisions make no sense to you, don't worry about it. I'm going to teach you how to do this on StatCrunch. So anyway, the first would be 0.18, so it's going to go up about to right there. The other is going to go up to 0.39, which is going to be about right there. And you'll see that what you get is a mirror image of what we get down here. Sometimes it's better to have this because it gives us relative frequencies, and we could get into conversations about probability. Sometimes it's nice to have this form because it gives us just the raw count. Now, these histograms, when they develop on out, and I want to go ahead and complete the top one. So I head out to 8. The next one would be a 3. The next was a 0, 0, and then out here we have a 1. So back to the original question, typical goals scored. Well, typical goals scored looks like from the picture, it's going to be between 12 and 16 because it has the highest bar. You might even argue that between 12 and 20, because these bars are pretty similar, gives you kind of a wider range on the typical goals scored. 19 falls in here someplace from the picture, because that was the second question. Is 19 unusual? And it looks like to me, because it's in that range from 12 to 20, I don't think 19 is unusual. It's a little higher than what I expect the average to be, but it's not out here unusual like the 30 5 or even the 21. So looking at this picture, typical goals scored somewhere between 12 and 20. Is 19 unusual? I don't think so. It falls in this bin right there. Now, guys, typically speaking, when we create these frequency distributions or relative frequency distributions, we call these things histograms. And for histograms, they kind of take on 3 shapes. One shape that we run into a lot in statistics may be something that looks like this. We will call this a bell-shaped and symmetric distribution. What you can think when you see one of these is that your mean and your median will be very close to the same value. In fact, the mean and the median will reside somewhere in this location right here, smack dab in the center of the distribution. Another type of a distribution that we run into a lot is something that looks like this. This is called a right skewed, and sometimes called a positively skewed distribution. Now, the characteristic of this type of distribution is that your mean is going to be significantly higher than your median. Now, I'll get into another video pretty soon that gets into that more, why that relationship turns out to be that way. But typically what happens is your median will be in this location and your mean will be out in this location. Again, there's a video coming up that'll demonstrate that. Kind of a mirror image of the positively skewed distribution. Would be something like this, and this is a left or negative skewed distribution. What you can expect here is you can expect your mean to be significantly less than the median. So the mean will be about this location, the median will be about this location. So what we do a lot when we first get back again to see it and summarize it, one of the questions that we will address in summarizing these distributions is whether or not we have a bell-shaped and symmetric distribution or a right skewed or a left skewed distribution. So guys, let's get out of this, and you will see that under Blackboard, I've put up another data set called goals, and I think I've already saved this on my desktop. Yeah, it's under number of goals. So what I want to do is I want to go to my Stat Lab, and I want to go to StatCrunch, and I want to open up the website. And I want to select a file on my computer. I want to choose the file. I want to get the number of goals. And I want to come down and load the file. Now, what we've got there is we have the 27. Is it 27? Okay. I thought we had 28. Where did I mess up? 4, 12, 17. Okay, I get 28. So I must have made a typo someplace in... let me try to figure that out. So I had, that's going to drive me crazy, 2 18s, 2 19s, looks like there's 4 16s, looks like there are 2 15s, looks like there are 3 14s, 2 4 5, 1 2 3 4 5, a 12. There were 4 11s, so I'm going to put an 11 here. All right, so now we've got the data set as it should be. So guys, make sure you add an 11, because I missed one when I went from the handout and typed it into the spreadsheet. So guys, what I want to do is I want to look at a histogram. So I'm going to Graph. I'm going to come to Histogram. And this is just variable number 1. I don't want to build anything. I don't want to group it. I don't have another categorical variable. Do I want a frequency or relative frequency? Actually, I'm going to do both, but I'm going to do frequency first. If I want to come in and start my bins at a certain place, I can do that, and that's what I did in the illustration. If I leave this as an optional, then there's an algorithm behind the scenes that will select that and give me the best picture. So I'm going to do that. And if I want to come in and give markers of the mean and the median, I'm going to do that. I can do it. Okay, I think I can even change colors. Yeah, it's got a kind of a color wheel here. So, all right, gang. So let's compute and see what we get. So if you notice, our histogram looks a little different. Why? Because it created bins from 0 to 10, 10 to 20, 20 to 30, 30 to 40. So it did bins a little differently. Actually did it on 5s. So I can hover over each bin, and it will tell me that there are 13 scores from 10 to 15. Now, look at it very closely. You'll notice that there's a bracket to the left of the 10, which means it includes 10, but there's a parentheses up to the 15, which means it's up to but not including 15. So if we had a 15, it would be put over here. So that's 15 up to but not including 20. Now if I went in and actually changed my bins to the way I did it, I started at 8 and the width of my bins was 4. I'm probably going to get something that looks, you must have selected at least one. Oh, okay. Shoot. I'm probably going to get something that looks more like what I created. And actually it looks a lot like it, as a matter of fact. I'm looking at it right now. It looks a lot like it. One thing, I can save it if I need. I want to go in and I want to show you what happens if we look at the relative frequency. And you guys, you'll see that it doesn't change it at all. It gives you the same picture. It just on the left hand, on the vertical axis, it gives you a proportion. It can be thought of as a percentage of each bin. All right, so we've got our, let's bring one of those back up. How would you describe that? Bell-shaped and symmetric, or right skewed? Well, because of this out here, we would call this a right skewed or positively skewed distribution. I would expect the mean to be larger than the median, which you can see that it is. All right. All right, so let's close this down. Let's open up another file. We had a file a while ago in a previous video called IQ Read. So let's open it up. Let's load the file. So I'm interested in seeing and summarizing read. So do histogram, read. I'm going to let everything else play out according to the algorithm. So what do I have? I have a left skewed distribution, or a negatively skewed distribution. I have 2 read scores between 0 and up to 20, but not including 20. I have 4 from a score of 20 up to, but not including 40, and so on and so forth. What would be a typical score? 60 to 80. Is a score of 19 unusual? Yeah, it's quite a bit away from the typical score. What about histogram for LSS? Again, let's make it happen. Now guys, I would call that a bell-shaped and symmetric distribution. This throws it off a little bit, but not enough to throw off the distribution. In fact, let's do that again and include the markers. So these things take a while to to do by hand, so we have 5.4 and 5.6. So those things are pretty close. But again, these histograms take a while to do them by hand, but not so much. Now this ACT is going to be kind of a wacky histogram because look, there's not a lot of variation. The ACTs only range from 18 to 21, so it's going to be kind of interesting to see how it does this. And I know how what's going to happen. It's going to separate them with just kind of a frequency within frequency classes. So we can see there that there are 6 scores of 18s, 8 scores of 19s, even though it says from 19 to 19.5, but we can look at our data and see that we don't have those. IQ, that would be interesting. IQs are typically bell-shaped and symmetric. I want to include the markers just for the sake of illustration. And we certainly do have a bell-shaped and symmetric distribution. Now, one thing you can do, you can see that we have a couple of other variables here, school district and gender, and these are categorical. Guys, it's not appropriate to create a histogram for either one of these variables. In fact, it won't even let you do anything goofy. It won't even include the categorical variables in the select column because that's not appropriate. But something that is appropriate might be to look at the IQs across maybe gender or a school district. So it is okay to take a quantitative variable and look at it over a categorical variable. And I don't like the way StatCrunch does this, but I get what I get, I guess. So this is for female, and to get male, I have to go over here. So I can go back and forth and kind of compare them, but I think it would be more compelling and more appropriate if we had those on the same graph. So what do you think? Typical IQ for males in this sample, somewhere between 110 and 120. Typical for females is somewhere between 100 to 110. If you're watching this with your boyfriend or girlfriend, don't even go there, or your significant other, because again, this is just a small sample. In fact, it's been shown that there's no difference between mean IQ scores between across gender, so there's no gender bias. Gang, that's really about it for this video. This is one kind of videos we like. It's not that hard and pretty easy concepts and not that long. So, guys, take care.